This is PopHealth Week streaming live on Healthcare Now Radio. I'm Greg Masters, your co-host and executive producer. Joining me in the virtual studio is my partner and co-founder, Fred Goldstein, principal host and president at Accountable Health, LLC. PopHealth Week is where we cut through the noise and get real about what's working and what's not in population health. Whether you're a payer, provider, patient vendor, employer, or policymaker, you're in the right place for practical insight and grounded experience-based perspectives. So, Fred, the mic is yours.
Thanks so much, Greg and Matt. Welcome to PopHealth Week.
Thanks for having me. Excited, very excited to be here.
Yeah, really looking forward to discussing this fascinating issue. So why don't we begin? Give us a little sense of your background and also talk a little bit about NLP Logix.
Yeah, my background personally is born and raised up in the Midwest. So grew up on a small farm just south of Fargo, North Dakota, and found my way into technology. Had a really good fortune of working early in my career for a company called Great Plains, which was later acquired by Microsoft, and just fell in love with technology there. Moved to Northeast Florida, here to Jacksonville, and met up with my business partner, Ted Willich, and around, that would have been, 2010, 2011 is when we started the company, but we worked at a previous company together, a healthcare company. And as it relates to technology, we were really just doing some interesting things with data and machine learning. And around 2011, thought it would be a good time to build a business that was focused on building AI and machine learning solutions for business, and built the company around that. And so we've been doing that for, going on 15 years now.
But you entered this competition in 2016. Tell us about that and why you did that.
2016 was a interesting time in the world of machine learning, because NVIDIA was shipping GPUs, but they were mostly at that time, mostly for gaming. They were for, my son has one or wants one at home, basically a beefed up gaming rig. And it was, the hardware was focused on optimizing graphics. And I think it was probably 2012, 2013, right around then, some researchers kind of hand rolled some machine learning algorithms that could leverage what GPUs are really good at. And GPU is a graphical processing unit. It's a little more specialized than, say, a CPU, which is so general purpose. It can drive everything that you're doing on your computer. But as it relates to GPUs, some researchers figured out that they were really good at training machine learning algorithms, specifically the ones that are designed using the neural network architecture, like a deep learning architecture. So that was happening in like 2012, 2013, 2014. And tons of progress was being made on the computer vision front. And in 2016, there was these series of challenges annually, these challenges called the Grand Challenges. And a lot of them had a healthcare focus. And the one that we were interested in was the Chameleon 16. And we were looking at that challenge because, one, it looked really hard, and we like to spend our time. We only have so much time here, so let's do some hard stuff and let's make it worth everyone's while. So we saw that challenge. It was to identify in digital pathology slides. It was basically identify the cells in a slide that would be, positive for cancer. It was what the scenario was. And I'm not sure, I had never seen a digital pathology slide, but they're massive, like tons and tons of data. My best way to describe these slides are, it's a little bit like Google Earth, which is you can get this very far out picture of kind of the tissue, and then you can really just keep zooming in and pinching in until you can see every single cell in that, in the slide. And it was really fascinating. And if you think of the pathologist, their job is to look I mean, this is a pretty technical definition, but to look at every single cell in that slide and then, identify the diagnosis based on what they see in the cells. And it's kind of amazing because you think of one of those slides, it could have a million cells, and how can you really get in there and identify anything? So it seemed like it was interesting because on this one hand, computer vision was really it was almost as hot, not quite as hot as like language models are today, but like in the world of machine learning, it was the hot thing. All the novel research is happening in computer vision. This is a really hard problem. It's basically pattern recognition at scale. And for us, it was just really exciting to think about, how can we add some value to the community, build an algorithm that is novel and unique and kind of advances the ball for everybody.
And this was an international competition with some pretty heavy hitters, at least name-wise, right?
I have to say, I'll be honest with you, if we would have known the names of who we were competing against, because it was MIT and Harvard and Google. Yeah, they had not. I don't believe they had yet merged in Google Brain, but it was, Google Research, and it was a really heady kind of a team. The teams that had entered were really the ones that were doing a lot of the great research in the area. And I'll be honest, yeah, like I said, I don't think when you see that, you don't think there's room for a company like NLP Logix to slot into that leaderboard anywhere. So we were very proud to show what our skills could do and bring some value to the field. And you're correct, it was an international competition, and it was actually kind of funny because I know it's 10 years ago because my passport, I just had to renew it because because it's 10 years ago. So we went to it was in Prague. We went over to Prague and we ended up on the podium with some of the folks from MIT and Harvard. And so it was neat to see NLP Logix on that stage as well and contribute to the overall advancements.
Yeah, my understanding is that this study was set up that they had the competitors get some images, with and without cancer in them, develop your model, compare it to new images, and at the same time, they used radiologists who were time limited in a sense to look at the same images and then see how well each group did. And so what were the final results about that when they looked at sort of I don't want to say head to head, but the comparison of the AI models to the radiologists?
And that's kind of what's interesting is what they did. If you think of a wide slide image that has a million cells on it, most likely it could be 100 of those million cells are the ones that are the problem. And so when it came to the training data, there was lots of examples of normal cells and a lot less examples of the cells that had cancer in them. And pathologists, their job, it was actually kind of interesting because you're right, they would give us all of the data that they had. I think, we started with, if it was, 200 or 300 of these wide slide images, and they told us that 100% of the cells that are in these images have been not just reviewed by one pathologist, but a team. And I believe it was three. They would each find the cells independently, and then they would look to see where they disagreed and agreed. And what ended up happening is, as the competition went on, the competitors would find new cases where the experts, the pathologists, had missed identifying where the cancer cells were. So it was kind of interesting, but you're 100% right in that we basically had what you call the training data. So we had wide slide images plus the annotations of where the cancer cells were. And then we had another set of wide slide images that did not have any annotations on them. And that's ultimately how you performed on those held out sets of slides is ultimately what stacked the leaderboard in the order.
Right. And I believe, if I'm correct, you guys finished top five at number 5 or something like that. up against these large international organizations.
Yes, we were number five. The rest were research institutes, so we kind of hang our hat on from a commercial standpoint. We were pretty happy with what we did. And then, your previous question was how did that stack up against humans, which I think is a really that was honestly that was probably the most interesting part of this whole endeavor, which was if you took the five algorithms and you merged the results into what you might call an ensemble. So if you took the five best algorithms, they were outperforming a pathologist. And that was if you read some of the write-up and the research, that was really unique at the time because it was one of the first examples of showing where state-of-the-art computer vision models, even back in 2016, were outperforming clinicians and experts in the field. And so that was really the novel kind of takeaway is when you combine these algorithms across these five teams, they're outperforming what a pathologist would do by themselves.
Mm-hmm. So as you think about this today, I mean, there's been a lot of, I don't want to use the term pushback, but a lot of concern about implementing these kinds of models and what might mean, how good are they, how should physicians consider this, what does it mean for the physician in their work? What do we understand about that now and the introduction of this potentially into the industry?
Yeah, I think I'll be honest with you, when we had done this 10 years ago, right on the heels of this, we set up a joint, we're here in Jacksonville, Florida. We set up a joint partnership with the Mayo Clinic. We built algorithms that did something similar for MRIs and CTs of the brain, looking for stroke and white matter hyperintensity. So we were very excited with thinking about how we can get these into a clinical setting, really adding some value. And I'll say, it was challenging enough for us that we decided that we'd be better off as a business if we still stayed in healthcare, but went to the back office of healthcare and helped with automation and efficiency, because especially 10 years ago, it's really hard to get these algorithms into production. And I think some of it is you really have to do the legwork and demonstrate that these are really positive for the patients. You are driving the right outcomes that you want to be driving. And so there's a lot of complexity in that, quite honestly.
And just a little side note, as I understand it, that technology ultimately got used in another sector for document analysis or something like that, and took off.
It's very interesting. It is interesting. We actually used the core bones of that algorithm that we did for Chameleon 16, the challenge, and we ported it. It used the same core infrastructure and algorithm, and we modified it and leveraged it to help us lift data off of claims and basically back office workflows. And we actually developed 4 patents around it. So it was for us, it was a great pivot. Hey, this is moving a little slower over here. This is moving pretty fast. Let's adapt the technology, wrap it in some patents, and then we're off and running.
Just tuning in, you're listening to PopHealth Week on Healthcare Now Radio. I'm Greg Masters, co-creator and executive producer, here with lead host and co-creator Fred Goldstein. Today we're joined by Matt Berseth, co-founder and chief AI officer at NLP Logix, one of the fastest growing AI consultancies in the country. Healthcare executives, if you're looking for low-hanging fruit, smarter operations, and a partner who understands both the technology and complexity of healthcare, NLP Logix is your team. Learn more at nlplogix.com.
And so when you think about that, obviously we're 10 years down the road from that. Where do you see it now? Are you beginning to see more interest in bringing AI back into clinical areas, or it's still mostly back office kind of use?
One of the competitors that the Harvard team, the MIT and Harvard, they ended up staying in this and taking it to market and using it as an assistant type of a tool. So I know that there's probably endless opportunity in developing algorithms for the clinical side of healthcare, but it really is it appears to be kind of a longer, slower road, and one that I think a private company that's not really married to a research institute, or for us, there's too many blockers. There's too much friction in that path for us, but I think it'll be a rich area as the technology improves. As I think part of it is as humans get more comfortable as a patient, as you get more comfortable with technology, and as a provider, as you get more comfortable with technology. I think that's the other half of the equation, is that we all need to be comfortable with it, understand how it works. And then I think there's definitely cases where it's going to be shown to be adding a lot of value for patients.
Yeah, I know as I think about it, just the amounts of data, as you talked about, the amount of data in those images is unbelievable. Well, then you start bringing in the genomics, the biomics, the rest of this stuff, and you're trying to take and understand individuals, and everyone's now talking precision medicine. Well, to get through those data sets requires some pretty good AI, I would assume, and machine learning models to understand and pull that together and come out with some sort of an answer.
Absolutely. I mean, you're absolutely right. Is that, and we're all wearing, I'm not, but everybody else in my family does. You got your rings, you got you have all this stuff, and all of that is just generating more data. And you kind of said it, as you correlate some of these things together, how can we have, what are the patterns between my ring and my watch and anything else I'm doing, and how can those help drive and inform patients to be, or individuals to be more healthy? I think all that is really an interesting area for some folks to focus on here now.
So, as a healthcare executive, if you put that hat on somebody out there, what should they be thinking about in terms of AI and its potential utilization?
As a healthcare executive, I think that I would be very interested in understanding, maybe not even, what we just kind of talked about there is, I think it is pretty, I wouldn't say like higher tech, but it's computer vision interpreting MRIs and CTs. Like that is fairly complicated things. I think there's a lot of lower hanging fruit. I know that if I'm a healthcare executive, I would be looking at my organization and saying, what are the things that we can do? How can we leverage AI so our providers can spend more time with the patient? Or what are some of the ways that we can optimize what we do operationally to help provide better outcomes for the people that we're seeing? And it's kind of amazing, because there's been an amazing uplift in just this core technology. Now I'm referring to Gen AI and LLMs. It's like we all have, to be quite honest with you, we all have on my phone here, on my laptop, we all have access to technology that 4 years ago, I think 90% of even the people in my field would have said this is just not possible. And now we have it. It's on our desktops. It's really table stakes. I would say let's look at ways that we can better use that core technology to help, be more efficient as an organization.
Could you give some examples?
I would, and these are going to sound silly. It's because it's going to sound like, well, that's not all that interesting. It's not as, it's just going to sound like, well, of course we should do that. Yeah, but are you doing it? And I'd say, something like that. One of the things to us that is really useful, and this is even as a technology company who are very comfortable with AI and building these algorithms from scratch, is we've got so much value out of meeting transcripts. We use transcripts, which sounds really kind of simple, but when you get a room full of people and they've put their pens down or their pencils down and they're engaged in conversations, you can, record those transcripts. And I was really amazed at how much knowledge is shared in those meetings, and having a high fidelity version of that you take and export, and then you're able to reshape to get, the valuable notes and action items and outcomes. All simple things like that. I just think that there are endless versions of that are available, those simple workflows that are available to an organization that really can just make them more efficient. And it's funny because you add those up, everybody wants to get 10% more efficient this year. Well, you add some of those up. Those are the low-hanging fruit that you can do as an organization and get uplifted this year. You still have time in 2026 to kind of implement some of those things and get those returns.
Yeah. Now, you started this organization with Ted and called it NLP Logix, but you go way beyond natural language processing. Can you talk a little about some of the various things you folks do, and maybe some of the areas your clients work in?
Yeah, we don't focus on any one industry. So we definitely span industries. I've talked a little bit about healthcare. We definitely do a lot in the back office of healthcare. And outside of that, we have we've done the sports media. We've done a big engagement. It's partnership with or in collaboration with the PGA Tour and AWS, Amazon Web Services. We helped build a commentary generation engine that the PGA Tour has on there. It was the coolest thing on their TourCast platform. It basically allows you to get summaries and recaps of shots as they're happening on the golf course. So it's a nice way to scale that out. We manage or help administer a scholarship platform that is, I think it has 500,000 students on the platform for the state of Florida. And even something like that, that is a big, a big platform that has a lot of really interesting kind of nuances that are really just, it's a great problem to solve. So yeah, so while we have our DNA is AI and ML, but right adjacent to that is data. So we do a lot in the data modernization space. And then same with modern applications. You cannot deliver AI solutions if you don't have the foundation of data, and if you don't have a delivery mechanism like an application to serve those solutions through. So while building models and algorithms, I think that's going to be core to everybody here. We all realize that we need to get these things out and into users' hands to really drive value. And to do that, we have to build whatever's required around it.
Mm-hmm. And I know you also do some work like with poison control centers and things like that as well. And
absolutely.
And recently, your imaging was used to help identify dolphins in the lagoon here, which is just a fascinating thing to help out with Hub SeaWorld and their dolphin rescue stuff, et cetera. So pretty amazing. Where are we going with AI?
So where are we going is a really good question. It seems to me that we are going to continue to have larger models that are more capable. So I don't think that trend, maybe we're just right now. I was actually talking to somebody about this earlier today, that maybe it feels like right now we might be kind of starting to slow down the absolutely upward pace of it. But there's going to be more incremental advancements and in the core models. And the harnesses that are surrounding them are absolutely making advances. And I consider those harnesses like the chat, you got Chat GPT, the application, that's different than GPT-5, the model. And for developers, the GitHub Copilot agent, that is a harness around, a core model. And so you're going to continue to see that stuff improve. But I do think it's interesting because I also think that as those models are so capable, there'll be interesting use cases for, models that are smaller, running on phones and laptops and other infrastructure than what you'll have at the hyperscalers. But I think people will probably start to fatigue, if they're not already fatigued, of maybe just the concept of AI constantly changing. but it feels to me like we are still going to see more and more compelling advancements, at least for the near future in AI. So, I mean, and from a business standpoint, even just broader than healthcare, even, there is just so much to be done across an enterprise in all industries. There's just so much to be built out. The capabilities are so far ahead of the adoption. There's just this huge gap. What can be done and what is being done. There is a massive gap between those two. That's what we want to fill. Like we want to be in that gap, filling it for our customers. But it's why it's such an exciting area, quite honestly.
So 10 years ago, when you entered that competition, did you think AI would be where it's at today? Could you see that?
No. If I would have got that NVIDIA stock. I did not. In hindsight, it seemed obvious, and I don't know how to. I'll put it this way: it was so not obvious. That foundational, the attention paper, that is the underlying piece of the core architecture of ChatGPT, right? That came from Google. So even they, kind of the original pioneers of that transformer, even they didn't see clearly and on what timeline what was possible. So I kick myself a little bit for not getting into NVIDIA, but I love where we're at the same time. I wouldn't want to be in any other field. I love exactly what we're doing. It's exciting.
So just in the final minute or so, you've talked a little bit about healthcare executives. What would you tell them to look at mostly?
I think that literacy is AI literacy specifically. I think that that's a really important thing organizationally. And I think part of that is this fatigue piece of, what is this? But I think really making sure your people understand some of the intuition around what AI is, how it works, where it's appropriate, where it is inappropriate, and get your organization rallied around that. And then I think as tools come and go, fads happen, but if you can get some literacy and understanding around the key pieces, I think that's the long-term play to have an efficient organization.
Fantastic. Well, thanks so much for joining us, Matt. It's been a pleasure.
It's been fantastic, Fred. I really appreciate being on here.
And back to you, Greg.
And that's a wrap for today, folks. A big thank you to our global audience for tuning in, and a very special thank you to Matt Berseth, the co-founder and chief AI officer at NLP Logix, for joining us today and sharing what 15 years on the front lines of applied AI actually looks like. The PopHealth Week streams live on Healthcare Now Radio every weekday at 5:30 a.m., 1:30 p.m., and 9:30 p.m. Eastern. And on behalf of Fred Goldstein, the entire crew at Healthcare Now Radio, and me, Greg Masters, stay safe, stay curious, and we'll catch you next time.